Hi, this is Mrs. Bustamante again, and this is the fourth video in our descriptive statistics series. We're going to talk about the 95% confidence interval. And we're going to talk about that because we left our last video discussing standard error of the mean and calculating it. Now we're going to kind of use it. And I told you that you didn't have to do standard deviation or standard error of the mean calculations probably on the AP test, but I will tell you that you do need to understand the information that they provide you, and you need to be able to use it correctly to interpret data, specifically in charts and tables. And the way this comes up most often is in something called the 95% confidence interval. So I'm going to tell you what the 95% confidence interval is not before I tell you what it is, because the name is a little bit deceiving. It does not mean that your data is 95% correct. I repeat, it does not mean that your data is 95% correct. What it does mean is that if you were to repeat your experiment 100 times, 95 of those times, your data would fall into this interval that we call the 95% confidence interval. If you were to repeat your experiment 100 times, 95 of those times would fall in this interval. Okay? And so to create our 95% confidence interval, we have to use our standard error of the mean. It's either going to be plus or minus 2 standard error of the means from the mean. So that means we're going to have two values when we calculate our 95% confidence interval. We're going to have what we call an upper limit, and we're going to have what we call a lower limit, because basically what we're going to do is we're going to go 2 standard errors of the mean up from our mean value and 2 standard error of the mean units down from our mean value. And that's what this equation shows me. It tells me my upper limit is equal to my mean or my average value plus 2 times my standard error of the mean. It also tells me that my lower limit is equal to my mean or my average value minus 2 times my standard error of the mean. Okay, so we're going to look at a graph here because I think that's going to help us understand what's being explained here. And we're just going to pretend that this graph I have right here is, I don't know, maybe I went out and measured the height of trees, and then I would count the height of all the trees, and I would put them together in this graph, and it'd tell me like how often I saw this specific height of the tree, and this was the height of the tree, right? So on this graph, I would have a mean, I would have an average, and it would be right here, right? This would be my mean or my average, my X bar. And if I wanted to know what the 95% confidence interval was for this data set that I was looking at, right? If I went 1 standard error of the mean up and then 2 standard errors of the mean up, which would just be a number that I had calculated, that would be my upper limit. If I want 1 standard error of the mean down and then another standard error of the mean down, that would be my lower limit. So basically I'd have these 4 bars, right? And this area all right here, that is my 95% confidence interval. If I wanted to just do 1, by the way, that 1 standard error of the mean above or below, that would be my 67% interval, right? So let's go ahead and do this for our data that we calculated, that we had in our other data sets, right? And that'll hopefully help us understand it even a little bit more. Okay, so we're going to do it for data set A, our upper and our lower, right? So our upper for data set A, remember our mean or our average was 3 plus 2 times my standard error of the mean that I calculated was about, we're going to call it 0.6. We're going to round here, but we're just going to call it 0.6 for the ease. 0.6, right? Which means I'm going to have 3 plus 1.2, which I can do that in my head, gives me a value of 4.2. And then, so this would be my upper A, upper A, upper A. Keep track of my information. Now I'm going to do my lower A, right? Lower A would be my same mean value, 3 minus 2 times 0.6. So that means lower A is 3 minus 1.2, which means lower value of A is 1.8. And these two values, in a second you'll see, are going to be what I'm going to plot on my graph here. So if I did it for A, right, I better do it for B. My upper for B is going to be what my mean value was, which was 3 plus, and then my standard error of the mean, I don't know if you remember, but it was 0. So it's going to be plus 2 times 0, right? So my upper of B is actually 3, and my lower of B is going to be my same mean, which was 3 minus 2 times 0, which will give me my lower of B to also be 3. Okay, let's box my values as my answers here so I can keep track of them. Know how to find them quickly when I need them here in a second. Okay, so now I want to use these on my graph. I started my graph, our graph for us down here, so we can kind of use it quickly without me having to take time to draw it. This would probably, I should probably give this a name over here. This would be maybe like whatever I was measuring, my mean of it, right? Well, these values that I calculated, and you'll notice that the mean of set A was 3 and the mean of set B was 3, so that's what my bar graph shows, correct? These values that I calculated up here, they're where I'm going to draw my error bars to on the graph. That is the value on the graph. Okay, so our 95% confidence interval values become what we call our error bars. So what do? We put a dot and our mean value, and then we're going to draw a line to our upper limit. So our upper limit for A was 4.2, and our lower limit for A was 1.8. So it would look something like that. And then for B, my upper limit was, my mean was 3, my upper limit was 3, and my lower limit was 3. So I'm just going to put a dot right there on 3. So what does this mean to us, right? Well, if the 95% confidence intervals overlap, we say that our data is actually inconclusive. And what that means is whatever we did, say we added fertilizer to one group and no fertilizer to the other group, it didn't cause a difference. And what that means is if any area of these error bars cross over each other, we can't say that whatever our independent variable is had any statistically significant difference on our data. We can't say with confidence, if you will, that it caused a change, right? So the bigger the error bar, the bigger our confidence interval, right, essentially, means that the more spread out probably our data is. And the smaller the error bar, the smaller the confidence interval, the more condensed our data is. And this is going to be something that we talk a lot about, and this is the real reason we want to be able to do all of this.